All right, so let's go ahead and read this problem. It's an airplane is traveling at a speed of 500 miles per hour at a bearing of 325 degrees. So again, bearings is popping its head. This is why we reviewed this last class. Once the airplane reaches a certain point, it encounters a wind velocity of 60 miles per hour in the direction of north 75 degrees west. Find the resultant speed and direction as a true bearing. So it wants us to take our direction angle and turn it into a true bearing. That's a extra at the end that we didn't have on the previous problem. So we're finding the resultant speed and direction of the airplane. First thing first, what should I do? What should I do first? Yes, exactly. We need to make a little diagram. Now, just to make sure I have enough room, I'm going to draw my diagram over to the side here. All right. And it tells us that the first path this airplane takes has a speed of 500 miles per hour and a bearing of 325 degrees. Where do we think of that bearing starting? Where does that bearing start? First of all, this bearing is a true bearing, right? Because it doesn't have an N or an S or an E or a W in the bearing, meaning it's a true bearing. And we need to remember or look back in our notes that true bearings start on the north line. So here my bearing starts on the north line and it goes 325 degrees clockwise. True bearings start at north line and go clockwise. So I'm going to go clockwise 325. Now, one quadrant is 90, two quadrants is 180, three is 270. So I need another 55 degrees. So that's about here. So I know this is 325 degrees. Now, when I am finding my vector and component form, do I use a bearing to find my component? So if we call this vector, if I'm trying to find this vector in component form, I know I have to use the formula, the magnitude times cosine of our angle, magnitude times sine of our angle. What is our magnitude? Yes, an airplane is traveling at a speed. Remember, speed is magnitude. So this right here is our magnitude. So I write a 500 in front of both of these. Now in the formula, when I said it's 500 times cosine of our angle, Our angle is not ever bearing. Instead, what it is a direction angle. Direction angles always start from the 0-degree angle, right? The positive x-axis, and they counterclockwise until they reach our angle. I'm sorry, our vector. So, how big is our direction angle? Direction angle starts at 0, goes counter. How'd you get that, Sophia? I did 90 minus 55 and then added 35 to 90. Perfect. That's exactly it. As always, there's many ways we can figure this out. What Sophia did, she remembered that we went past 270, 55 degrees to get to our vector, right? And then we know one quadrant is 90. So she did 90 take away 55 to get that this is 35. And then to get our direction angle, you have to add it to another 90. So what she did was 90 plus 35 and got 125. So this is 125. What I would have done, obviously there's many ways you can do it. I would have done 360 because look, it's starting from the north line, going all the way around, almost fully around, but you're missing this little part here. So you can do 360, take away 325, and it will give you 35. Then you just do 35 plus 90 and get 125. Any questions on how we got that 125? Okay, so now we can go ahead and finish finding the component form. We just take out our calculator, make sure our calculator is in degree mode, which mine is, and then we go 500 cosine 125, and we get negative 286.79. And then we do the same thing, but for sine to get our y value of our component form. And we have 409.5. So that is a component form. Now we need to do the exact same process, but for B. Sorry, for the second vector here, which we're going to call B. It says it encounters a wind velocity of 60 miles per hour. So that's our second magnitude there. What purple? So this right here is our second magnitude. And in direction of north 75 degrees west. So this is a quadrant here. This tells us where we start and where we end, and how many degrees we go in between. So we're starting from the north line because that's our first letter. We're going 75 degrees towards the west. That's towards the left. So from north, we're going 75 degrees, which is almost 90, but 15 degrees short. So that's like this. That's like right there. That is 25 degrees. That, of course, is another bearing. And we now remember to get our component form, it doesn't include the bearing. What it actually includes is the direction angle. So how can we get our direction angle? Remember, direction angles start from 0 and go to our vector. So what do we do to get our full direction angle? Which, I know there's a lot drawn here. Where can I draw this? We'll do it this. How can I get this full direction angle? From 0 to our vector. Yeah, yes, guys, yes. We know that from the north to our vector is 75. And we also know that quadrant 1 is worth 90 degrees. So we get the full direction angle. It's just 90 plus 75, which is 165. I don't know why, but my pen is not working well today. Like 165. 1. So then all we now need to do is plug both of those into our calculator to finish getting our component form. 60 cosine 165 gives us negative 57.96 if I'm rounding to the hundredths place. And we do the same thing but sine to get our y value. And we have 15.53. So now what? Great. We have both of the vectors in common. Great. Now what? See why isn't writing? Why did we do that? Why did we have to get them in component form? I'll give you a, what color should we do? Orange, I guess. This is the keyword right here. Resultant. Not yet, Sophia. Not yet. What do we have to do before we find the magnitude of the resultant force? Or velocity, I think in this case. Yes, velocity. Yes, we have to do. Anytime you see the word resultant, you know you're going to have to add vectors together. So that's what we're going to do right now. We're going to add A plus B. All we do to add is just add the A values or X values and add the B values or Y values. Now I'm going to use the ones right in my calculator. I have the negative 286 number plus the negative 57 number. I'm doing this because it saves me time and also it's actually more accurate to use the full numbers in the calculator, right? Because I'm not rounding in the middle of the problem. And then we add the Y values. And you get 425.11, rounding the hundredths. Now that I know what my resultant velocity vector is, my addition vector there, now I can find the speed and direction, knowing that speed is actually magnitude. So first I'm going to find the magnitude. We find magnitude of component by using the Pythagorean theorem. So it's going to be that A term squared plus the b term squared. And we get 547.32. And what is our unit on that number? What is our unit? This is a magnitude. Yes, miles per hour. Wonderful. Our magnitudes, our speeds have MPHs on them in this problem. And lastly, we find the direction angle. To find direction angle, you always use inverse tan of the b value. Oh, that's supposed to be 5 over the a value. So inverse tan of the b value over the a. And we get -50. Now, what? Should I circle it? Done. No. No, I should not, because remember, when our calculator is finding the direction angles, we need to think about what quadrant our vector is in. So if we're looking at this vector a plus b, -344 and a +425 means that this vector is actually in quadrant 2. What do we do to vectors in quadrant 2? Add 180, yes. In quadrants 2 and 3, we add 180, and in quadrant 4, we add 360. So here I may have to use a different application because this is just killing me. So our true direction equals 129.04. Now, again, should I circle this? Are you done? Remember, what did I say? Did we have an extra step on this one at the very end? I know it was way back, 18 minutes ago. This problem is so long. True bearing, yes. This is a direction angle, meaning if I were to graph it really quickly, this angle is 129.04 degrees. How do I get the true bearing, which starts at the north line and goes around to here? There's a couple ways to get to it. You want me to just how I would do it? Let's zoom in here. So what I would do is I would recognize, okay, this true bearing goes through 3 quadrants, 270, and then it has a little bit more. I just need to figure out, okay, what is that little bit more? To figure out what that little bit more is, all you have to do is take 180 and you subtract our direction angle. Because together, the direction angle and this little bit make a 180-degree angle. So we have 180, take away our direction angle, 50.96. And then what do I add that number to get my full bearing? 270, good, because it has 3 more quadrants. So I add another 270. So here, my true bearing is actually 320.96 degrees. So that's the second part of my problem. That's the direction angle as a true bearing. And the first part of my problem was speed. All of that work to get 2 numbers. Are there any questions on this problem?